welcome to Asian Tech Forum. Today, this is another video in ASA firewall video series, and in this video, we are going to achieve a very important thing, right? Because if you are running a firewall, I'm sure you are doing more than regular home internet. So if you are a small enterprise or small office, maybe you are hosting some servers within your network, right? And so what we are going to do, we are going to understand what is a port forwarding, how to configure port forwarding within Cisco ASA, and we will tackle it in two ways. First via CLI and then ASDM, because ASDM can give you a very nice visual representation of what we are doing. Then obviously we will verify things in both ways, right? So let's understand why port forwarding. Okay. Uh, So this is a typical scenario. As you can see, I have a firewall facing internet and towards outside interface, and there is an inside network. There can be another leg also, DMZ. So that doesn't matter, but there is the main thing is there is a secure network inside and there is a less secure network which is facing outside internet, right? And firewall is in between doing our firewall filtering plus NATing for us, right? By default, this is a NAT device. That means it is protecting public subnet 192.168 or 10 dot something and bind that with your ISP provided public IP addresses. All right. So in typical scenario, all your inside network, they try to reach out to various applications and services, websites on internet, and they come back while firewall take care of the NAT. So it's mostly outgoing connections. When port forwarding is required is the scenario where you have a server, you're hosting some application on this server, and you want to expose this server to the outside world. That means a user sitting outside your network uh, can connect to your server, can initiate a connection to your server just by internet. That means it's not a VPN or any dedicated connection. It's just he's connected to internet and he can connect to your server. So for that, what we need to do, we need to do a server static IP address mapping and also a port translation. So basically, this user can connect to the outside interface using certain port number, and when it happens, firewall look at the PAT table, port address translation table, and see what is my incoming connection and how to translate it to. Because you may have multiple number of connections inside, right? So that's why firewall actually look at the PAT table and see who to hand over this connection and to what port, because this server may be running multiple applications on different port numbers. So that is what port address translation, and that's what we are going to achieve in this video. I hope things are clear here. So let's go ahead and see how to configure. So first we will look at the steps in the command line CLI. Steps are very simple, three-step process. First, you define your server. What is the server you want to expose to the internet? Then define PAT for your server on firewall, right? The NAT/PAT on firewall. Then obviously just defining a port address translation rule is not enough. You have to also define a access list, because there are some implicit protection is there on firewall, right? So no one can access uh, things from outside to inside by default. These are like some global rule, and we will see that those global rules even before we start configuring or poking a hole within our network. Okay, so these are like three-step process. You need to know what is the server you want to expose, what application port number it is using, then go to firewall, define the PAT or NAT rule, and then finally open an access list. So this is irrelevant to whether you are using a Cisco product or any other product. This is the thing you have to do for port address translation. Now, if you're using Cisco ASA, basically this is the command line, and I'll explain what we are doing here. So ignore about the name but this name can give you a feeler that what is coming next, right? So this is my server, host 192.168.1.125, okay, and this is where I am defining my PAT rule. So basically what I'm saying, NAT inside outside static interface service TCP 1884, translate it to so this is the source, this is the destination. So anything which is coming with 1884, translate it to 18840. So this will be the expose port which you are going to publish to internet. All right, and since we are saying static, so there's going to be static binding between my dynamic IP address, and that's where we am saying interface. So it will use my dynamic IP address of my outside interface, and it will bind that IP address with my server IP address, and this is the port binding. So on server you are having a TCP port 1884, and that will be binded to 18840 when it goes outside, and vice versa. All right, now the final part. So this was the section 2. Now the final thing is we need to open a access list, right? And for access list also, do not just go and say permit outside any, right? Because it will make your host vulnerable. So the best way is to identify the subnets from where the users want to access your this server. So identify that, and that's what I'm doing. This is my object network, and I have a host sitting in Oracle Cloud, and from that Oracle Cloud I'm going to access this MQTT broker server. And here is my access list rule, which says permit TCP my OCI host to MQTT server, which is sitting inside. And obviously you need to apply this access list to the interface, outside interface, using access group. So simple configuration, simple concept, right? So this is from CLI. Let's see what ASDM gives you, right? So from ASDM, you have to come to configuration. Within configuration, click on firewall. Within firewall, two places you have to edit rules. First, the NAT or PAT rules, and then open the access list. So look at the NAT rules, right? And even before we look at the NAT rule, what we want to look is access rules, and look at the implicit rule. Okay, what is my implicit rule look like? So let's first look at the inside implicit rule. It says one implicit incoming rule, source is any, destination is any less secure, and permit. That means if a traffic coming from any source but it's going to any less secure interface, egress interface is less secure, allow it. Otherwise, do not allow it. That means if you are coming from inside and going to outside, right, you are allowed, because you are going to a less secure interface. So that's the implicit rule. Another implicit rule is global if any deny, right? So source and destination any is by default, it's denied. So no one can come from outside to inside by default. Okay. So these are my implicit rules. Now, so you know how to what are the implicit rule, and we have seen the command line, right? Command line is pretty simple, but it's not that intuitive, right? If you want to do things with the ASDM, which is more intuitive, and there is a visualization available for your rules, uh, what you can do, it's a hierarchical, right? So you cannot just, it's not a flat, it's hierarchical things. So basically what you have to do, you have to come to configuration and tackle these two tabs, NAT rule and access rule. When you come to NAT rule, first create few network objects, right? So you can say network object, and let's call it, I'm going to clean it up, so but let's call it, this is our inside server, right? Server. And then you can say whether it's a host, it's a subnet, and all those things. So I'm going to say this is a host, and let's call it 999 something. Okay, I'm gonna say okay. Obviously one extra, and then what you can do, we'll create, so this is my inside server. And then let's create another network object which we are going to call in access list and say this is outside server. Outside server. And let's call it 10.10.10. So one is 9, one is 10. Okay, so we created two network object. And now let's go ahead and create a NAT rule. And we are going to say network object rule. Name is delete. Okay, add network object. We already have a network object created. So let's call that network. That was inside. All right, now we already have the NAT created. Okay, so let's do add, yes, add a NAT rule basically, right? Not a static NAT, pardon me about that. So I'm saying that source is inside, destination is outside, source address, okay, it opened in extended desktop. So inside to outside, and the source address is my inside server. Okay, select that. Destination address is can be any. All right. And services, you can also go ahead and create a service here, right? So sorry about that. Things are going in the extended window. So here, when you come, you can, yes. So you can create a service, right? You want to restrict things just to say certain TCP port protocol and port, that you can do by creating a service object. So you can name the service object, you can choose the service type with the TCP, UDP, and any other protocol, and put the port range here. So for example, we are not going to say any particular service, but that's fine. And then what you are going to do, your source net type is static, source address is original, and destination address is also original. Okay. And service type, obviously, you can create another service type calling it to the new port number. Okay, that's what you can do. And simple, you can say enable rule. But obviously, we are not going to create any new rule. And when you do the access rule, here also, you just have to come here and say add a access rule interface. It's coming from outside, so I'm going to say outside source. Source can be anything, or if I know the subnet, right? I know what is my subnet, then I'm going to define that subnet here, that port forward test, right? So you can name it, and under that you can have the IP addresses. And finally, the destination criteria is what? Destination criteria is my network object, which is MQTT broker. Okay, and then you can have like services and all, but those are not needed. I'm just saying that if this port forwarding test host coming in outside network, coming to the outside network, and allow it going to MQTT broker services IP. You if you want, you can select TCP also, but that's okay. Okay, so these are the two things you are going to create. So we are not going to create a new rule. So let me quickly clean up things and delete the outside server, inside server, and we will focus on the rule, existing rule. So if you want to see the access rule, you can see I already have this access rule which says port forwarding host coming to this and this, allow. Okay, IPTCP. I want to edit this because the IP address is not correct. So how I can do that? I can obviously cannot edit the rule here because it's part of network object. So let me go to network object and change the IP address. We will set the IP address to our OCI VM. Okay, let me quickly find my OCI VM IP addresses. Sorry about that. Okay, Let's go back and I'm going to apply this. All right, you need to hit apply so that it can take effect. Okay. So that was my access rule. It's not showing yet, but should okay, let me try to do a refresh. Okay, because it's still showing 75.7. all right, we want to see the new IP address, so let's go and check our new rule. Port forwarding, yes, this is a new rule shown here, right? NAT rule is already created, so anyone coming here with port 8840 should be forwarded to 1884. All right, so these things are all the things are in place. What we can do, we can validate things now. All right, how to validate things? If you want to go to monitor, you can actually go to properties, interface. Let me just expand it a little bit. Okay, right, let's go to, oh, there is, all these windows are collapsed, so let me align it properly. Say properties. Okay, so monitoring, properties, under properties you come to scroll down, and just after WCCP you have connections. All right, here you can see all the connections, whatever is going on within my network, you can see everything here. So let's filter with 192.168 1.125, because that's what our inside server host is, right? So right now you can see there is no connection, active connection, okay, because we have not made any kind of connection on port 1884. All right, if we have to validate that on ASA itself by CLI, what you can do, show xlet and then say include 192.168 1.125. okay, as you can see I have a TCP PAT rule created. Okay, now let's test things. So basically, first what I'm going to do, I'm going to start a server script on my Raspberry Pi, which is a server, and make it listen to port 1884. Okay, looks like the session is hanged, so let me log into 125 again. All right, host is down. I think I have to troubleshoot the host, make it bring it back, and then we can continue our validation. But I'm sure you understood the rule, how to configure the rule from CLI and from ASDM. I'll set this thing correct, and we will make a validation real quick. Thank you. I just reboot my Pi, and as you can see, the Pi is back up. Let's validate the IP address 192.168.1.125. Let's make it listen to our port number. So we'll start a WebSocket. Okay, let's start -TANLP. Let's see what it is listening to. Okay, it is already listening to 1884. Nice. All right, so let's go to our OCI port, and this is my cloud VM. It already has a public IP address. So let's create a client program. I already have a client program. So this is a simple server client program, and yes. All right. So as you can see, it created a connection to my inside host using that public IP address and public port, and I'll show you the program in a minute. All right. So let's watch this in ASDM log. All right. So let me start the logs. Okay, because what we want to make sure, that we are seeing that 132 tunnel IP address. Okay. So let me say this is a test. Okay. And let's keep an eye here. 132, we should see 132. Okay. I'm gonna pause this, filter with source IP addresses, and let's see if we have anything coming with 132. So ASDM logs does rotate real quick, so it's very difficult to capture this point in time on this syslog screen unless you are like exporting it to somewhere. So let me first show you the program here, TCP client, and it says that this is my IP address and this is my server port. Go ahead and create a TCP client request. So let's do that again. And while we do, we are just quickly going to go and capture this in ASA. All right, let's stop it here and try to see if we have anything with our 132 IP address. Okay, again, nothing here. So let's go to monitoring and connections and see if we are getting any connections there. So connection graph, scroll down, you have to come to connections, and within connections just try to filter with 125. Okay, filter, apply the filter, refresh, filter. As you can see, I have this TCP connections on port 1884, right? You can see that. So this is the port number, and let's do a packet walk and try to see the NAT action and everything uh, in action. Okay, so what we are going to do, next is we'll go to this monitoring state and then open a packet tracer. Okay, within this packet tracer, this is our final validation. We are going to say outside, and IP address is 132, and let me see. Okay, so I need to see the IP addresses of both 68.1.125. Destination port is 18840, and source IP address is my OCIVM. Okay, so my OCIVM IP address is here. Source port can be anything random, right? For that, what you want to do is you want to capture this and filter. Okay, as you can see, the ideal time session is open 38736. So you can use any random port number 38787 and say start. Okay, destination port too high. Okay, start. As you can see, it's giving you the complete packet walk, what is going on, access list, route lookup, access list, NAT lookup, and all those things from outside. Okay, the packet is dropped inside because I mentioned a private IP address here. I did it intentionally because for outside network, they do not see your inside IP address by default, right? So for that, what you have to do, you have to use your outside IP address and then run your tries to evaluate your policies. All right. Sometimes I do the mistakes knowingly so that we can recreate scenarios. Okay. So now I'm tracing from OCI to my WAN using a dedicated destination port. And let's see what different objects are being evaluated. Okay. Packet is allowed. But is packet allowed uh, how we expected it to go? So for that, let's check. UN NAT, okay, and you can always cross launch. It will go back to ASDM. But see, this is our inside network, MPQTT broker, and this rule is hitting this NAT rule. Okay, this packet is hitting this NAT rule. So this is good. This is what is expected. And then it is allowed by using that ACL. So you can see that ACL is allowing that traffic. And then there is a per session NAT and all those things. We are not going into that. Again, you can see it's hitting the NAT rule. And finally, a flow is created with new ID and result of the packet is allowed. So basically the packet is going as expected. It's not hitting any implicit rule or anything else. It's basically going from outside to inside using our NAT rule plus access list. All right, so this is all I just wanted to show you guys and how you can validate your policies, make use of packet tracer, wonderful tool. And again, going to configuration under firewall, you have to create NAT rules, access rules, and by creating your network objects. All right, I hope the things are clear, and if you have any questions, do write me in comment section, and I'm going to post the GitHub link for CLI configuration in description section as well. So thank you for watching